Now, we're going to learn in this video about what's called the variance of the data and the standard deviation of the data. Instead of trying to define those things, let me show you how we get those statistics, and then we'll try to come up with some kind of definition for it. So here's our data set, organized from smallest to largest. That's helpful. And then our mean was 18.125. Now I want to stop using the word mean here, and I want to start using our notation. In statistics, we use the letter X with a line over it, and we say X bar. That's what we say. We say X bar. And X bar is the symbol that we use to represent the mean of a sample. Okay, so the sample mean, X bar, is 18.125. And the letter that we use to represent a single data point, like 11, is just the letter X. And so if I just say X, I'm referring to a single data point. If I say X bar, I'm referring to the mean of the sample data. Now, what we're going to learn about first is a concept where we take a data point, like 11, and we subtract the sample mean from it, okay? So we take the data point and subtract the sample mean. So in this case, we would take 11 and we would subtract from 11 18.125. And if we do 11 minus 18.125, we would have a negative number, negative 7.125. Okay? This is called a deviation from the mean. A deviation from the mean. Okay? It's how far the data point, how far is X away from the mean? And is it smaller than the mean? Then it's negative. If it's larger than the mean, like 22, it'll actually be a positive number. And these deviations from the mean are very important in understanding the behavior of a data set, okay? And so what we're going to do here is we are going to identify all 8 of these deviations from the mean. Just like we identified 11 as a deviation from the mean, we're going to identify all of them as a deviation from the mean. So now we have identified all 8 of our data points and their deviations from the mean. So now if we take this negative 7.125, the deviation of the data point 11 from the mean, we can take that negative 7.125, and if we don't want it to be a negative number, we can take the absolute value of it, or we can square it, or something like that. And so what we typically do in identifying the variance is we take this deviation from the mean and we square it. And so negative 7.125 squared is equal to 50.7656. Now I've actually rounded this, but it's that's approximately what negative 7.125 squared is. And so this is called the squared deviation from the mean. The squared deviation from the mean. Okay? Now, this squared deviation from the mean is another really important number. We said the deviations from the mean, well, we said that the mean is an important number, and we said the deviations from the mean are important in statistics. Well, now I'm telling you that the squared deviation from the mean for each data point is very important in statistics. And so what we're now going to do is we're going to take all 8 of the deviations from the mean and we're going to square all of them. And so now we have 8. Because we have 8 data points and we have a mean, we have 8 squared deviations from the mean. Now you'll notice that 2 of them are the same, and that's because 2 of our data points are the same, and that'll always happen. And now that we have these 8 numbers that are called the squared deviation from the mean, we are ready to identify the variance. So here is how we identify the variance of a data set. Now the variance is represented by the letter S, lowercase s, squared. So we call this S squared, or the variance of the sample data. And here's what we do to identify the variance. It's very similar to finding the mean. Remember with the mean, we added up all the numbers. Remember we added up all the data points and then we divided by how many data points there are? Well, we do something very similar with the variance. Here's what we do. We add up all of the squared deviations. And then we divide that sum by we would divide by how many data points there are, but there's sort of a strange mathematical phenomenon, and what we do is we divide by how many data points there are minus 1. So in this case there are 8 data points, so n is 8, but we're going to subtract 1, so we're actually going to divide by 7. And so we are going to add up all of the squared deviations in the numerator and then divide by 7. Now here are all of the squared deviations. Here's 4 of them and here's 4 of them, and I'm not going to write them all out, but basically we're going to add these and we're going to add that. We are just going to add them all together, and once we add them all together we're going to get 290.8748. 290.8748. Now if you want to go ahead and pause the video and add up all these numbers yourself, you go ahead and do that, or you can just take my word for it that it's 290.8748. All right, so this is 290.8748 divided by 8 minus 1, which is 7, okay? And so if we go ahead and do this in a calculator, we would get S squared is equal to approximately 41.55357. Now we typically report this at, well, a lot of times we're going to report it in my class to 3 decimal places. So we're going to go to here and we're going to round this 3 up to a 4 because this is a 5 right here next to it. Okay, so we're going to say that the variance S squared is 41.554. Okay, and now we're going to identify the standard deviation, which is actually really easy. We use the letter S, not S squared, it's just S. Now note that S is the square root of S squared. S is the square root of S squared. And that's actually what we're going to do to find the standard deviation, okay? So S, in fact, let me reverse this. We'll say the standard deviation of a data set, which we typically represent. Now this is the sample standard deviation. We use the letter S, is equal to the square root of the variance. So whatever the variance is, we just take the square root of it. And in this case, that's the square root of 41.55357. We want to use the unrounded number since we're doing a calculation on it. And so this will actually give us 6.446. 6.446. And so S, the standard deviation of this data set, is 6.446. Okay? And now the last thing I want to say in this lesson is, well, how can we understand the variance? How could we describe, like give a name to what the variance is? Well, remember how I said that this is very similar to calculating an average, okay, where we added up a bunch of things and then divided by how many there were? Well, we call that an average. So in a way, the variance is kind of like the average of all the squared deviations from the mean. And so I'm going to write that down here. And that's our introduction to variance and standard deviation.